I want to do a video on the Key Easy 4017 chaser for programming the EEPROM write code using the Arduino IDE. I'm just going to go into the Documents folder, and under the Arduino folder, previous labeled the Arduino Projects folder, this one just happens to be named plain Arduino. Open that folder up. Inside that folder is all of the project folders that I've been working on. This is the one we want to focus on right now. It's the keypad burn EEPROM write folder. So we open that one up, and here you can see that the two files that were downloaded reside in that folder: the keypad burn EEPROM write and the EEPROM write function file. Okay, so I'm going to go over to the Arduino IDE now. I already have the code loaded down for the keypad burn EEPROM write, but I'll go over quick how to do that. Click the File tab, open, do the drop down, Documents, Arduino folder again, double click it, search for the keypad burn. Here it is right here. I'll get it down here. Keypad burn EEPROM write folder, the one that we're after. Double click that, open it up. Okay, here are the two files that were downloaded. Highlight the keypad burn EEPROM write. The EEPROM write function will attach itself to this file when it's downloaded to the Arduino. So you just have to highlight this one and open. And when it's downloaded, your Arduino IDE should look something like this. Okay. There's two folders. There's the keypad burn EEPROM write, that's the main code. There's the EEPROM write function folder. This is the one that writes and reads from the EEPROM. We'll go over how these tie together in a moment here. To start, you have to include two libraries: the wire.h library, that's for the I2C bus, and the EEPROM.h library, that's for the EEPROM. There's some variables that are declared here. There's 3 integer variables and 1 character variable. In the setup, the wire.begin code opens up the I2C bus, and the serial.begin 9600 opens up the serial monitor communications. This set of code here, basically all it does is flush the serial monitor buffer. I just wanted to be sure that the buffer is empty before any more data is put into it, so no false data gets sent down to the Arduino. Okay, now in the void loop, of course there's the delay. Then the serial monitor will print out, enter the EEPROM address location to store the character. This while loop will keep running until some data is entered into the serial monitor and sent down to the Arduino. When that happens, the code will continue on, and the serial monitor will print out you entered an EEPROM address of, and it will go and it will retrieve the data out of the serial monitor buffer with this serial.parse integer piece of code here, and it will store it in the EEPROM address integer variable that was declared up top. Okay, then the serial monitor will print out that EEPROM address on the monitor just to give us verification that the proper address was stored. Okay, then it'll come down and it'll call this function again, the serial flush buffer. I just wanted to be sure that that data that's in that buffer, the serial monitor, is cleared out before we enter anything more. So it would jump up to this function here, and it would just run this function to clear this buffer in the serial monitor again. When that's done, the code will continue on, and the serial monitor will print out, enter the ASCII code decimal value for the character that we want to store in that EEPROM address that we just entered up here. Again, the while loop will just sit here until some data is entered on the serial monitor and sent down to the Arduino. Then the serial monitor will print out, enter the ASCII code decimal value of. Again, it will go read the buffer on the serial monitor and move that data into the EEPROM ASCII variable here that was declared up top. Okay, this piece of code here would take that decimal value that we entered, and it's going to convert it to a character. This is all done internally in the Arduino IDE, because remember, if you remember up top, this character variable is declared as a character. Okay, so it'll automatically convert that to a character, and then the serial monitor will print out ASCII code decimal value converted to character, and then the serial monitor will print out the character that decimal value represents on the ASCII table. Okay, then it'll come down and it's going to call this function now, the EEPROM write function. So it's going to jump up to this folder here and open up this folder. Again, I just declared these two lines of code again, with the wire begin for the I2C bus and the serial begin for the serial monitor, just to be sure they're opened up. It's probably not necessary, but I did it anyhow. Okay, then what happens then is we want to initiate a write down to the EEPROM. So the serial monitor will print out write EEPROM function initiated, just letting us know that it is initiating the write function down to the EEPROM. And then it will initiate a wire.begin transmission to the EEPROM address. And the EEPROM address is declared up top here in the main code. Right here, defined the EEPROM as 0x50. These are the pins 1, 2, and 3 on the EEPROM that was grounded, and by grounding all three of them, that address is declared as 0x50. Okay, so it's going to open up that communications on the I2C bus to that EEPROM with that address, and then it's going to write the EEPROM address decimal value that we entered in the main code, and it's going to write that EEPROM address decimal value that we entered into the main code for the character that we want to store, and then it's going to end the transmission. Okay, and then it's going to print out write EEPROM function finished, so it's done writing. The next step is we want to read it back to make sure that the correct data went into the correct address cell on the EEPROM. So again, the serial monitor will print out read EEPROM function initiated. So it's going to do a read function now. It's going to again wire begin transmission to that EEPROM address, opens up the communication link on the I2C bus to the EEPROM. It's going to wire write the EEPROM address that we're going to request the data from, and then it's going to end the transmission, print out that the EEPROM address being read from, and then it's going to just display on the serial monitor what address we are requesting, just for our verification that it's requesting the right address. The next step is to request the character stored in this EEPROM address. Again, it will do a wire request from the EEPROM address, and this number 1 here is basically stating that we're requesting 1 byte of data from that EEPROM cell location. And if the wire is available, which means if the communication link on the I2C bus is open, it's going to do a wire read, and it's going to store that data that's in this EEPROM address in the ASCII code value variable that was declared. It's going to end the transmission. It's going to display finished reading from the EEPROM, that's done, and then it's going to serial print ASCII value read, and it's going to print this ASCII value on the serial monitor just to verify that the correct decimal value was read from that EEPROM cell address. And that's it. It's fairly simple, and I hope you enjoy.